All right, guys, today we're going to do lesson 112 and 113. And 112 is applications of the Pythagorean theorem. So remember, when you have a right triangle, a squared plus b squared is equal to c squared. Okay, so if we know it's a right triangle, we can find missing sides. But if we wanted to verify that a triangle actually was a right triangle, we could, for example, down at the bottom of page, whatever page that is, 782, if they gave us three numbers and they asked us to tell if those three numbers formed a right triangle, then what we would do is, remember, the hypotenuse is the longest side. So if I have 3, 4, and 5, and I want to know if that forms a right triangle, the two legs don't matter which one we plug in for, but we have to plug in for C, the longest side. So in this case, the longest side would be 5. So I'm going to say something is equal to 5 squared because I know that that 5 would have to be the hypotenuse. The other two sides don't matter what order they go in, but we have to have the longest one plugged in for C. So let's just check it. If it's equal, we know that this is in fact a right triangle. If it's not equal, then it's not a right triangle. So this is 9 plus 16 is equal to 25. 25 is equal to 25. So yes, it checks, and these are the sides that make a right triangle. So we can use it both ways. We can find missing pieces if we know it's a right triangle, and we can determine if it is a right triangle if we're given the sides. So they had a little activity. Unfortunately, we don't have time to do it. So if you'll look over on page 784, it says the numbers 5, 12, and 13 are a Pythagorean triple. So they've already worked it out. They know that is a triple. They want us to figure out what are the next three triplets. So the really cool thing about the Pythagorean theorem is once you find a triple like this right here, if you multiply it by any whole or any counting number, it's going to make another right triangle. So the first one, this would be considered that number times 1. So if we multiply this by 2, the next triplet would be 2 times 5 is 10, 2 times 12 is 24, and 2 times 3 is 26. All right, that's also a Pythagorean triple. Since they want 3, we're going to go up to 3, and then we'll also do 4. Okay, so times 3, what would that give us? 3 times 5 is 15, 3 times 12 is 36, and 3 times 13 is 39. And then times 4, 4 times 5 is 20, 4 times 12 is 48, and 4 times 13 is 52. So all of these are also right triangles. Okay, they're triplets. Okay, the next example says a roof is being built over a 24-foot room, wide room. So this is 24. The slope of the roof is 4 in 12. Okay, that means it goes up 4 and over 12. All right. Calculate the length of the rafters needed for the roof. Include 2 feet for the rafter tail. Okay, so this would go up 4 and over 12. All right, so here's the middle. Here's what we've got here. And that's the rafter. It comes down like this. And they're going to say that this is going to be 2, but we're not going to mess with that right now. What we need to do is find just the length of this rafter, and then we'll add to it to find out what those beams would have to be. All right, so this is 12, and this is 4. So we're looking for C, aren't we? Remember, it's across from the right angle. And we know this is a right angle. If it's not, You need to fire your contractor because he's not good at making right angles. We know it's a right angle. That's what they're telling us. So we're going to set it up. 12 squared plus 4 squared is equal to c squared. So that's 144 plus 16 equals c squared. Let's see, what do we get? 1, 4, that's 4, and 6 is 10, 2, and that's 160. And so C would be equal to the square root of 160. So that's what this would be. Then we have to add 2 feet also to it. So 2 feet, and I'm not we don't use a calculator, so just leave it as square root of 160 plus 2. You can see in the book that decimally that comes out to be 12.65, add the 2 to it is 14.65 feet. So, and I don't think they asked for it to be in inches. Did they not just ask for it to be in feet? Needed for the roof. They don't specify. So just leave it in terms of feet. So that's all you would have to do. Okay, one more. Bottom of page. What is that? 785. It says, Serena went to a level field to fly a kite. She let out all 200 feet of string and tied it to a stake. Then she walked out on the field until she was directly under the kite, 150 feet from the stake. About how high was the kite? All right, so what you have to realize, I don't know how many of you guys have flown kites before, but she tied the string to a stake and the kite's going to be like this. So she let all 200 feet of the string out and she walked from here underneath the kite. I'm not going to try to draw a kite. How about if I just draw the tail of the kite? All right, so she walked 150 feet away until now she's directly under the kite. And they're asking us to find this. All right, so it is a right angle, okay, because she was directly underneath the kite. So, oh gosh, we're going to use Pythagorean theorem. So remember, across from the right angle, that's the hypotenuse. So that's going to be equal to 200 squared. And h squared plus 150 squared. So that's h squared plus, see, 15 times 15 is 225. So that'd be 225 and then 2 zeros. And this is 4 with 1, 2, 3, 4 zeros. So if we subtract, we get h squared is equal to 0, 0, 10 minus 5 is 5, 9 minus 2 is 7, and 3 minus 2 is 1. So it's 17,500. Now here again, we're not using calculators. So just you can just leave it at that. You can see in the book that it's approximately 132 feet, but we're not going to use a calculator. So you would just leave your answer as the square root of 17,500, and that will be acceptable. We're not going to use calculators. Okay. I think I better shut this down and make a different video for the next lesson. It'll be too long if I don't. So I'll give you the message at the